Hi everyone and welcome back to my channel A in Economist. So today what we are going to do, we are going to solve some problems on econometrics, some numerical questions on econometrics. Specifically, I have given you questions on CLRM, right? So I have talked about CLRM, the theory portion is already covered. You can watch my detailed playlist that is been uploaded. And I'll also give the link in the description. If you haven't watched my playlist, you can check that out and then come back to this video. And in today's video, let us see some of the questions that can come. And we'll see different kind of questions that might come in your exam or in general. If you are economics and econometrics enthusiast, then these questions might help you to clear your concepts, right? So let's look at this. The question number 1 is saying the following sums were obtained from 16 pairs of observation. So n is given to you as 16. Number of observation is given to you as 16 on x and y. So you have two variables. As I've told you in classical linear regression model, it is basically a two variable simple regression model where you have one independent variable and one dependent variable. X is the independent variable, y is the dependent variable. And the data on x and y are given to you. So see, the first data is this summation I from 1 to n yi square is given to you. Summation xi square is given to you. Summation xi yi given to you. Summation yi, summation xi. So these are the data that are given to you. Now the first question is asking estimate the parameters of the model. So in this model, see, the model looks like this. The simple two variable regression model, we have worked with this model multiple times before. So this is the kind of model that we see in two variable linear regression model, and you have two parameters here, namely alpha and beta. So firstly, you have to estimate what will be the value of alpha, what will be the estimated value of beta, and r square. So this is question number 1. And then what you have to do, also test the hypothesis that beta equals to 2. So here the slope, you have to test the hypothesis that the slope parameter is 2, basically, which means that the impact of x on y will be 2. Basically, the slope is 2 means the derivative. Slope is just the derivative. The derivative is 2 or not. So to test that using hypothesis testing, also you have to specify the standard errors of alpha and beta and estimated error variance. So estimated error variance is basically sigma cap square. Remember, we have proved the formula of this also. We have derived all the formulas. So this is basically an all-in-one question where everything, your entire concept of CLRM will be tested, right? So I have formulated the question in that particular way only. So now let's go ahead and solve each of the parts of this question, and that will help you to clear your concept, right? So the model that you have is given to you as this: yi equals to alpha plus beta xi plus ui for all I from 1 to 16. You have 16 observation altogether. Now, if you remember, by the OLS method, we have derived this entirely manually, that what is the estimated value of alpha cap. Remember, what was the estimated value of alpha cap? It was simply y bar minus beta cap into x bar. Right? We have derived this from the normal equation, from the first normal equation, basically, where this beta cap is simply the beta cap OLS. So this will be alpha cap OLS. And what was beta cap OLS? Beta cap OLS was simply summation I from 1 to n. Then you have xi minus x bar, yi minus y bar, and then you have summation I from 1 to n, xi minus x bar whole square. Right? So this was the formula that we have derived, and it can be again written as Sxy upon Sxx, notationally. Right? So this was alpha cap OLS and this is beta cap OLS. This was the formula. Now see, you are given this observations here. This data points are given to you. Using this data points, you have to estimate the value of alpha cap and beta cap. So let's see how we can do this. Firstly, focus on beta cap OLS. In the numerator, you have Sxy, right? Now, if you try to expand this numerator, what you will get, if you try to take the product and take the sum, if you do that, the numerator will come out to be xi yi minus nx bar y bar, right? The numerator will come out to be this. You can try this on your own. Just take the product and do some rearrangement. You will get this. Summation xi yi minus nx bar y bar. And in the denominator, how will you expand this? Just take the whole square and take the sum on each of the terms. You will get something like this. Summation xi square minus nx bar square. Right? So we have expanded the numerator and the denominator to, get a workable form. Basically, now you can use the data set that is given to you and solve this question. See, summation xi yi. What was summation xi yi? It is given to you 492. Put the value here, 492. Then you have n x bar y bar. N is 60, x bar. Now for x bar, you see summation xi is given. So what is x bar? Summation xi upon the total number of observation, which is 60. So basically 96 upon 16. Similarly for y bar, what is summation yi? It is 63. So 63 upon 16. In the denominator, what you have? Summation xi square, which is 657 minus 16 into x bar whole square, right? So this will be the entire expression. Now I have already solved this expression. You can do this on your own in your free time. You will get something like this, 114 upon 81. And this will come out to be 1.407, right? This is what you will get. You can try this at your free time. I am not going into the details of the solution. That is what you will be getting, right? So this is beta cap OLS. Now, once you know beta cap OLS, you can simply find out what will be alpha cap OLS. What was this? It is y bar minus beta cap OLS into x bar. This is the formula. So y bar is what? Y bar was 63 upon 60. Beta cap OLS is simply this, which we just found out. And then you have x bar is 96 upon 60. Now again, if you calculate, this will come out to be minus 4.5045. You can do the calculation in your free time. You will get alpha cap OLS to be this. So what we get from here is that this is the estimated slope parameter, and this is the estimated intercept parameter. Right? So this is how you have to solve the first part of the question. We have found out what is alpha cap OLS and what is beta cap OLS. This is basically the estimated parameters of your model. See the first part, estimate the parameters of your model. So this part is done. Now next, look at the second part, find out what will be the value of R square. Now, if you remember, what was the formula of R square? R square is simply ESS upon TSS. Remember, R square represents the proportion of the variation. R square represents the proportion of variation of the dependent variable y, which can be explained using the independent variable x in your model, right? And this was the expression ESS upon TSS. Now, remember what was TSS? Can you remember this? What was the formula of TSS? Simply I from 1 to n, yi minus y bar whole square. This was the formula of TSS. Now, remember one thing. Now, let me get back to the question. Remember one thing, that all these terms are given in exact variable terms. In the variable terms, capital X and capital Y. We are not talking about the deviation form. Remember, we have told you that small xi means capital X minus x bar, and small y means capital Y minus y bar. So x and y, capital X, capital Y, they are the original variable, whereas the small x and small y, they are in the deviation form. Now, in many times in question, you will see the formula or the data will be given in small x, small y terms. So please very, careful about in which terms the data is given to you. Here, they are given in the original terms. In the next question that we will solve, we will see in the deviation form as well. Then I think this will be more clear to you. Now let's see how do you find out R square. So basically whatever we are doing here is in the original form, that is capital Xi, capital Yi form. Now this is the deviation form, summation yi minus y bar whole square. So this yi minus y bar means small y. right? Now again, you can solve this thing in the similar way. This will be summation this into ny bar square. Now summation yi square is given to you. See, this is simply 526. So the first term is 526 minus 16 into, this is 63 upon 16 whole square. Now again, if you calculate, this will come out to be 277.9375. So it will come out to be approximately this. And what will be the value of TSS? Sorry, this is TSS is done. What will be the value of ESS? Remember the formula for ESS? I have again derived this. If you haven't watched those videos, please check that out and you will see how am I, deriving this thing. Entire derivation is done. I have uploaded 25 videos. In that you have everything with every formula that you need to know. So this can be again written as beta cap square SXX. They are the same formula. Beta cap SXY is the same as beta cap square SXX. We will use this particular thing here. Beta cap square. Beta cap square means beta cap OLS whole square. See what was beta cap OLS? This simply this 1.407. 1.407 and the whole square of that. And SXX. SXX, remember, see, this was the denominator. This is SXX. What was the value for this? What is the value for this? If you see, this was simply 81. You can calculate, you can do the calculation. You will get that this value will come out to be 81. Now, simplify, you will get 160.3515, something like this, right? This will be the approximate value of ESS. This is the approximate value of TSS. Now simply take the ratio and you will get the value of R square. So what will be R square? 160.3515 upon 277.9375. Again, I have done the calculation. I have got something like 0.5769. You can check the calculation. You will get something approximately 0.6. Approximately this will be 0.6. Right? This is something that will come. So basically what it says is that 60% variation, approximately 60% variation of Y can be explained by the variable X, right? That will be the interpretation. Or if you get 0.75, then you can say that 57%, approximately 57%, whatever you get. Actually, this is in decimal, basically. That is why, calculation might vary. You can check your own calculation. So 0.75 to 0.60, anything will do, right? Any range between this will do. Some variation will come in my calculation and your calculation due to this decimal part, but that doesn't matter. Approximately 60% variation of the dependent variable Y can be explained by our independent variable X, right? So this is second part of our question. See, estimate the parameters of the model and then find out R square. This part is done. Now next look at this part. Test the hypothesis that beta equals to 2 and then specify standard errors and the estimated error variance. So how to solve the hypothesis testing portion. So what you have to do, you have to set the null hypothesis against the alternative hypothesis. What is your null hypothesis? Slope parameter beta is 2.0, right? Slope parameter beta is 2.0. This is the null hypothesis against the alternative hypothesis is what? Beta is simply not equals to 2 points. So basically it's a two-tailed test. Two-tailed test that you have to conduct. Right? Now, can you tell me what is the distribution of beta cap? Do you remember what is the distribution of beta cap? We have derived this. Previously we have solved question also. How to solve this? So if you remember, beta cap follows a normal distribution with the mean beta. And what was the variance? Variance was simply sigma cap squared upon SXX. Remember this, we have derived this thing, that beta cap That is the estimate. This is the slope parameter, estimated slope parameter that will follow. That is basically a random variable that follows, that has a specific probability distribution. It follows normal distribution with mean beta, and the variance is this. Where what is sigma cap square? Sigma cap square is the unknown error variance. It's basically the error variance. Error variance, estimated error variance. Right? Now all you have to do, you have to define the test statistic. What will be the test statistic? Test statistic is simply T given by beta cap minus beta under H naught upon the standard error of beta. What is the standard error of beta? It's simply the square root of variance. Standard error of beta is simply sigma, let me write it in this way only, sigma cap square upon Sx, right? Sigma cap square upon Sx, and under H naught, this will follow T distribution with n minus 2 degrees of freedom, right? Under H naught, it will follow T n minus 2 degrees of freedom, and that will be your test statistic. Now, simply you have to find out a couple of things. Firstly, find out what is sigma cap square. This is the estimated variance. Remember the formula for this, RSS by n minus 2, right? We have derived this for 2 variable case, it is RSS by n minus 2. If it is 3 variable case, then it is RSS by n minus 3. In general, for k variable, it is RSS by n minus 3. This is the formula. Now, what is RSS? What is RSS? RSS is simply TSS minus ESS. And this is simply n minus 2. Remember the decomposition of TSS. TSS can be decomposed into ESS plus RSS. Again, I have proved this thing. So how will you write RSS? RSS is simply TSS minus ESS. That will give you RSS, right? Now, TSS we have found out earlier. What was that? 277.9375. Something like this. What was ESS? It's 160.3516. N was 16, so it will be simply 14. Now, if you calculate, RSS is 117.5859 and upon 14. So this will come out to be 8.39899. So this will be sigma cap square, and this is one of the questions. Sorry for that. This was one of our questions in the problem that we are solving, that what will be the error variance. See, what will be the error variance? So error variance we have already found out. This will come out to be something like this, 8.39899. This will be the estimated error variance. Now, if you have this, you can simply find out the variance. The variance, because see, this is the numerator and the denominator is Sxs, which we have already found out. So what will be the variance of beta cap? It is simply sigma cap square upon Sx. So this is 8.39899 upon Sx was 81. So this will come out to be 0.1039369. Something like this. So what will be the standard error of beta cap? Standard error of beta cap will be simply the square root of this. And this will come out to be 0.3220. You can verify this for yourself. You will get something like this. So standard error of beta cap, we have found out. This will come out to be 0.3220, right? Now we have all the values to compute the computed value of the T statistic. So let me compute. So what will be the T computed? That is the statistic value. So beta cap was what? Estimated value of beta is this, minus the beta under H naught is 2, and upon the standard error, which is 0.3220. And if you calculate this, this will come out to be minus 1.8416. Right? So what is the absolute value of t computed? What is the absolute value? This is simply 1.8416. And what will be the critical value? See, this is a two-tailed test. This is a two-tailed test. So what we will do? We can write something like this, 0.05, and then you have to divide this into two parts. That is why this, and the degrees of freedom is n minus 2, which is 16 minus 2 is 14. So this will come out to be t 0.02514. Have to find out this value. Now this value will be given in your T table in any of your statistics books or in your econometrics book. I have seen the value. This will come out to be 2.145. Right? You can, see your books. You will get this thing very easily. It's already given there, right? So what we can see from these two things, what we see is that the T computed value is strictly less than the T critical value. This is the T critical value, right? This is the T critical value. So T computed value is strictly less than the T critical value. Diagrammatically, if you see, this is something like this. So this is suppose a T distribution and the critical regions are like this. The critical value you have got is 2.145. So here you have 2.145 and here you have negative of 2.145. And these regions will form your rejection region. These regions will form your rejection region. Now, see what is your computed value? 1.8416. T distribution is symmetric about 0. So 1.84 will be something like this, right? So it is in the acceptance zone. This black shaded region, this is the acceptance zone. So our computed value of T is in the acceptance zone and not in the rejection zone. So you have, this is one of the rejection zones. This is one of the rejection zones, but our computed value is not in the rejection zone. So what we can say, we can conclude that we failed to reject. We failed to reject our null hypothesis at 5% level of significance. At 5% level of significance, that is alpha is basically 0.05. That is, beta can take the value 2.0 in our present regression model. So our present regression model at 5% level of significance, right? At 5% level of significance, beta can take the value 2.0, which is, given by the data that is provided to us. So this portion is done. Test the null hypothesis that beta equals to 2.0. This portion is done. Now the only thing that is left is to find out the standard error of alpha and beta. Now see, standard error of beta we have already calculated by computing the statistic. So that is done, and the estimated error variance, that is also done. So you have to find out what is the standard error of alpha. Now, do you remember the formula of variance of alpha? Do you remember the formula of variance of alpha cap? What was that? The formula was this, sigma cap square 1 upon n plus x bar square upon sx. This is the formula. Now we have got all the values. We have got all the values. Sigma cap square was 8.39899. This was sigma cap square. That is the estimated variance, error variance. 1 upon n x bar square. So x bar was 6. So x bar square is 36 and sx was 81. Now if you compute all these things, you will get 4.25782. So what will be the standard error? The standard error of alpha cap, this will come out to be 2.06344. Right? So this will be the answer for all the parts of the question. We have solved all the parts. So let me go back to the question and see what we have done so far. So the question is a kind of all-in-one question where you are asked to find a lot of things. So firstly, you have to estimate the parameters of your model and R squared, which we have done here. See, these will be, you can basically take a screenshot and do it for yourself. You can try the formulas. So you have to only just put in the values. You have to, firstly, from the formula, you have to derive a form with which you can work with, right? So I have converted the formula in this particular fashion and then put the values. You will get this estimated values of alpha cap and beta cap. This is the estimated slope parameter and the estimated intercept parameter of your model. Now, once you do that, you can find out R square using the TSS and ESS. TSS formula and ESS formula I have given to you. See this formula, take a screenshot, do whatever you want and do it for yourself, right? Don't copy this thing, just do it for yourself. That will make your concept clear. And then we have gone into the hypothesis testing portion where we have checked for the slope parameter can take the value 2 or not, where we have seen that yes, we fail to reject the null hypothesis and we can conclude that yes, our slope parameter can take the value 2 at 5% level of significance. And finally, we have found out what will be the standard error for alpha. Previously, we have found out what will be the estimated error variance and standard error of beta, right? So this is how you solve this question and all the portions are done. Now let us look at the last question for today, which is question number 2. Now see, the why I have given this question is that this is in the deviation form. The data points that are given to you, all the data that are given to you are in the deviation form. See, this is small xi, this is small yi, this is small xi yi. Previously, the question that we have solved, all the values are capital. See, capital yi, capital xi, capital xi, yi. So the formula that you are working with will be changed when you work with deviation form and when we work with the original data points, right? The process will be the same, only some of the formulas will be reversed. So see how to solve this particular question. We'll solve this and then I'll stop. So these are the data points that are given to you. N is 27 now. So first part is the same, estimate the parameters in the model. And then you have to test the hypothesis. H naught remains the same. H naught is beta 1.5 against the alternative. You have to test. This is two tail test. This is the right tail test and this is the left tail test, right? So let us see how we can solve this problem. The model is the same. Yi is alpha plus beta xi plus ui. Now for this model, how do you find out beta cap OLS? Beta cap OLS is Sxy upon Sxx. Now in the deviation form, how do you write that? It will be simply I from 1 to n, small xi small yi upon small xi square, right? This is the same formula we have used previously. Let's look at this. This is the same formula. See, xi minus x bar is small xi, yi minus y bar is small yi, and then you have small xi square, right? So this is the formula that you have to use for this case. Now the values are given to you. See what are the values. Xi yi is 200 and this value is given to you as 100. So this value will come out to be 2. So beta cap OLS is 2. Now what will be TSS? TSS is simply summation I from 1 to n yi square, small yi square. Now what is this value? This is 500. What is ESS? It's given to you beta cap Sxy simply equals to beta cap square Sxx. Beta cap we got 2, so it will be 4. And then summation xi square, small xi square. So 4 into this value was given to you as 100, so this will come out to be 400. So we have the value of TSS, we have the value of ESS. So how do you find out RSS? Simply TSS minus ESS will give you RSS. So it is 500 minus 400, which will come out to be 100. Now sigma cap square is simply RSS upon n minus 2. RSS is 100. N is 27, so it will be 25. So this value will come out to be 4. Right? So we have all these values. Now what you will do, and now in this problem, you can simply find out alpha cap OLS as well. Y bar minus beta cap OLS into X bar. Now see, Y bar value is given to you here, X bar value is given to you, And beta cap OLS value is also given to you. You can just put this here and solve the value, right? This you can consider as your homework. There is nothing to, show here. Just put the values and solve what will be alpha cap OLS, right? Now let's go into the hypothesis testing in this question. Sure. By the problem, the null hypothesis remains the same. Beta is 1.5. This is the null hypothesis against the first case. In the first case, the alternative is two-tailed test. So 1.5 beta not equals to 1.5. So this is the question. Now, firstly, find out what will be the t computed value, and t computed will be the same for all those cases. So firstly, for t computed, simply as I've told you in the previous question also, under the standard error of beta cap. So what is the estimated value of beta? We just got it to be 2. See here, this is 2. Now beta cap under H naught is 1.5, and then you have to find out standard error of beta. Standard error of beta, sigma cap squared upon Sx6. So sigma cap squared is 4 upon Sx6 will come out to be what? This is 100. So if you put the value here and solve, this value will come out to be, you can do this for yourself, this will come out to be 2.5. So the t computed value that we got here will be the same for all these cases. So this is simply 2.5, only the critical values will change. Now, how do you test the hypothesis? For the two-tailed test, what is the t critical value? T critical value is simply this into n minus 2, which is 25. From the statistics books or econometrics books, you will see this value is simply 2.6, 2.060, and the t computed value we got as what? 2.5. It's simply 2.5. So the scenario is something like this. This is the t distribution. T distribution is symmetric about 0. Here you have two rejection regions. This is one of the rejection regions, and this is another rejection region. What is this value? The critical value is 2.060, and here you have minus 2.060. And where is our value? The value is 2.5. 2.5 is way here, which is in the rejection region, right? Which is in the rejection region. So what we can say is that the t computed value, the mod value of t computed is strictly greater than the t critical value. Hence, what we will say, H naught is rejected at 5% level of significance. LOS means level of significance. So, beta cannot be 1.5 at 5% level of significance, right? So, this is the first part of this question where we have solved this two-tailed test. Now, let's look at the right-tailed and the left-tailed test. So, here for all the cases, the t computed value will remain the same. So, t computed is still 2.5 basically. Only the t critical value will change. Now here, how do you find out the t critical value for the right tail test? We are doing it for the right tail test. Alternative is beta greater than 1.5. So there will be only one rejection region, and you don't need to divide the level of significance. It will be completely 0.05. And then you have, this is 25 in minus 2. Again, if you see from the statistics books, it will come out to be 0.708. So now the scenario is like this. This is the t distribution. I'm drawing a freehand diagram, so please pardon me for that. It's a freehand diagram. T distribution will look something like this. Here you have, here you have only one rejection region, not two. Here you have only one rejection region. This is a right tail test. See, this is a right tail test. Here you have only one rejection region. This value is 1.708. And what is our actual value? Computed value is 2.5. So again, it is way here. it falls into the critical region. So T computed value is strictly greater than the T critical value. So what we say again, reject H naught. H naught is still rejected at 5% level of significance. Right? This is the second part. And finally, we go into the third part. T computed again remains the same, 2.5. Now T critical will be what? T critical will be simply the negative value of what we got earlier. So 0.05 this, but now we will take only the negative side. See, this value remains the same. Here we have taken the positive side, here we will take the negative side. So here the rejection region will be on the negative side. This will be the rejection region now. This is the rejection region. This value is 1.708. What is the, so what we can say? This is 2.5. This is the computed value and this is in the, is this in the rejection region? The answer is no. Now, the T computed value is like this. T computed value is mod value of that is greater than minus of T critical values. So basically, T computed falls into the acceptance zone. This is the acceptance zone. T computed falls into the acceptance zone basically. So what we can conclude, we can say that H naught is not rejected. H naught is not rejected at 5% level of significance, and beta can be 1.5 at this 5% level of significance, right? So this is how you solve the entire question. So here we have done two numerical questions on CLRM. Let's do a quick recap of the question number 2. Here the only intention of giving this question is to show you how to work with the deviation form. Previous question was with the original variables with the original data form, and now this question is using the deviation form, and this is how you solve it. So here this is your homework. Please do this. How to find out alpha cap OLS. All the values are given. Just compute and let me know in the comment section what you get as the alpha cap OLS. And the rest of the portion is simply as we have seen in the previous question. We have found out TSS, ESS, RSS, estimated error variance, and then we have gone into different kinds of hypothesis testing. So this is, we started with two tail test, then we have gone into the right tail test, and then we have gone into the left tail test, and we have seen how to tackle each of the parts, right? I hope this video is helpful to you. If you want more of these videos, you can let me know in the comment section. And in the next video, I will go into a problem set regarding the multiple linear regression model, and we will solve questions on the portions we have covered so far. So stay tuned for that. If you like this video, give me a like and do subscribe to this channel in Economist. That gives me immense motivation to continue making these videos for you. And thank you so much for your time. Let's meet you in the next video.